All right, so we're going to learn something called the binomial theorem. And to get there, we're going to talk about stuff that you should have done in Algebra 2 last year. So some of this should be somewhat familiar. Should have, I said. X plus y to the 0, what's anything to the 0 power? X plus y to the first?
X plus y.
X plus y to the second?
X squared plus 2xy plus y squared.
How are we getting that middle term for those of us that don't remember how to do this? You have to do FOIL, so you have to write like the other one. And you have to do FOIL, and then you combine your middle terms, and you get 2xy. So now the third one. You would need to take like the second one and multiply by one more. Let's do it in a different color. You would take this one, the second, and you multiply by one more, and you need to do FOIL and combine all your like terms. This is the answer that you would get. Anybody know the first term you get?
X cubed.
Cubed. Do you know what the last term is? Y cubed. That is correct. The coefficient for the second term is a 3. Do you know how many x's there are? 2. Do you know how many y's there are?
1.
And then we have another 3. Do you know how many x's there are?
1.
And then how many y's?
2.
All right. So you look at the x's and the y's, and for the exponents, the x's are going starting at 3, which is the original degree of the question, and going down, down, till there's 0. And then the y's start at 0 and go up, up again, up. They just increase by 1 each time, till there's the total number that we need. Another thing you look at, actually let me do one more and then I'll tell you the other part. What do you think this one is here? That one's x to the 4. What do you think the last one is? That is correct. The next term starts with a 4, and then x to the third, y.
My bad.
And then we have a 6, x squared, y to the second, and then we have another 4, x to the first, y to the third, right? So if you look at the exponents, when we're taking it to the 4th power, there's 4 in this term. This term, there's 4. Oh, that was supposed to be red. In this term, there's 3 x's and 1 y. That's a total of 4. In this term, there's 2 x's and 2 y's. That's a total of 4. In this term, there's 1 x and 3 y's. That's a total of 4. And in this term, there are 4. So in every single term, there's going to be the same amount of variables. It's just some for each term, or some for each variable. I'm not saying that right. The total degree of each term is that number there. There's something else that you need to notice. Well, yes, and it's not always going to be x's, but the x's always go down, the y's always go up, or whatever's in this spot. Looking at the coefficients, so this is 1, this is 1, this is 1, this is 1, 2, 1. This is 1, 3, 3, 1. This is 1, 4, 6, 4, 1. There is patterns. What does it always start with? 1. What does it always end with? 1. The second term, with the exception of the first, the second term, it's always the exponent that we had. It's always the exponent. So when I did the 3rd power, that's a 3. When I did the 4th power, that's a 4. It's like always the same. The rest of it, we'll go over how to get that. Do you guys remember doing this? Maybe some of you. Okay, I don't want to hear from some of you, but because I know what you're going to say. Does anybody remember how doing this stuff last year?
Yeah.
Some of you remember? What's this called? It's called Pascal's triangle. And Pascal was a mathematician. To get any number on this triangle, you take the 2 numbers above it and add them together. So to get any number in this triangle, you take the 2 numbers above it and you add them together.
The number.
So what's the next row? What's the next row? 1.
5, 10,
Wait.
This is your car.
Oh, okay.
Alright, okay.
So these are the coefficients. These are the coefficients. Now, when we did x plus y to the 4th, which row was x plus y to the 4th? It is not the 4th row. It's the one that starts with 1, 4. When we did x plus y to the 4th, it was the one that starts with 1, 4. This would be to the 5th power. So you can't go by the number of rows because what's the first row? The 0 row. So these are the coefficients for each term when you multiply a binomial. So let's put in a couple more rows. 1, 6, 15, 20.
So do you always have to put a 1 on the other side?
Always starts with a 1, always ends with a 1.
Oh, right.
And there are some really cool things about this, but we don't have a lot of time, so I'm not showing you them today. Sorry. So what would x plus y to the 5th look like?
4, 5, 10, 10.
So I'm going to start by writing 1, 5, 10, 10, 5, 1. I'm going to start by writing those. Then I'm going to look at my first term in the binomial. And we do what with the first term? We go in descending powers. We're going to start with x to the 5th, then x to the 4th, x to the 3rd, squared, x. And then the last term has none of them in it, because it would be to the 0. The one thing that could be tricky is that one of the terms has to the 0 power. So when you do the second part, when you do the y, or whatever's in that second spot, how many y's go in the first term? None of them do. It's y to the 0. And then we've got y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, and y to the 5th. So then after that, put plus signs in between everything. Those are all separate terms, and terms are separated by addition. How many terms, when I do the 5th power, how many terms do I have? I have 6 total terms. You will always have one more term than what that exponent is. Because that one of them, either the first one or the last one, has that 0 power. So these are patterns, and this is using Pascal's triangle to expand a polynomial without actually multiplying it all out. Because if I had to do this by hand, I'd have to put 4 parentheses, FOIL 2 of them. Take the next one, FOIL it with the 3rd one. Take that answer, FOIL it with the 4th one. That's a lot of work. Or we can just use Pascal's triangle. So let's do Pascal's triangle. It's the 4th power. What are the coefficients going to be? 1, then 4. So I know which row to look at. 1, then 4. What comes after that? So that came from my triangle. What if I'm not given Pascal's triangle in a quiz? Very easy. You just add the 2 numbers above it. As long as you can get the first 1, 1, 1, then from there you just add the numbers above it and put 1s on the outside. Even adding the numbers above it, even adding the numbers above it on the side, like what number is above that? Nothing. So that would be a 1 over there too. So you can even use it there. All right, so those are our coefficients. Then we do the first term is now 2x. It's not just x, it's 2x. So how many 2x's are going to go here? You need to have 2x in parentheses to the 4th. Right. Because we're going to have 16x to the 4th, not 2x to the 4th. The entire first term in that binomial. So then we'll have 2x to the 3rd. We'll have 2x squared to 2x to the first, and then 2x and 0, which is not really there. Then the second term is -3, and you need to include the -3. Do I put it in this one?
Nope.
So then start here with -3 to the first, -3 to the second, -3 to the third, -3 to the fourth. And then go put some plus signs in between all those terms. Now we're just going to simplify each term. So I kind of already said the answer to this one. 16x to the fourth. Then for this one, I have to do 4 times, I already do 2x cubed. That's 8x cubed. So I have to do 4 times 8x cubed times -3.
Minus
96x to the third. So you'll have to, you might, use your calculator quickly to multiply those numbers together. This term, I'm going to do 6. I'm going to have 2x squared, which is 4x squared. And then -3 squared is just +9. So it's going to be positive. I think it's this. I'm trying to remember. The next term will have 4 times 2x times -3 to the third, so -27. So I know it's going to be a minus. Yes. Okay. And then the last one, -3 to the fourth, that's 4 negatives, so it becomes positive. 81. So we just expanded out that binomial without actually multiplying it all out. So for this one, it's to the third power. So my coefficients are going to start with 1, 3. And then I finish that row, which is what? 3, 1. My second term is x squared, or my first term is x squared, so I'm going to do x squared how many times? 3. See how I use parentheses? And then we're going to have x squared squared. We'll have x squared to the first, and then x squared to the 0, which I don't need to write because it's just 1. And we're going to do 2y. So we'll do 2y. Nope, we won't do it there. Just kidding. Stop me. 2y to the first, 2y to the second, 2y to the third. Then we're going to go simplify our terms. Remember, when you do power to a power, you multiply your exponents. So x to the 6, yes. When you're doing something like because that's like x times x times x times x times x. This one's x squared times x squared times x squared, which is 1, 2, 3, 4, 5, 6. All right, plus, then we're going to do 3 times 2, so 6, x to the 4, and then y. Yes, so 7. There's a 2 right here. There's a 3 right there. 2y to the first. The next one I have 2y squared, so I actually have 4y squared times 3, so 12x squared y squared. And then the last one will be 8y to the third. Remember, wait, something's wrong. No. Remember that, no, that's not going to help you on this one. I don't know. Just stay organized, that's all. Okay? We good? So how would you do x plus 3 to the 18?
Not me.
Tell me what the coefficients are going to start with. 1, 18, and then how many total terms will there be? 18. Like 19 total terms. So there's got to be other ways of finding the answer besides just making Pascal's triangle like infinitely large. I don't even know if you'd ever want to do this. So what difficulties will we encounter? It's like a huge triangle. It's a lot of work. They have come up with other methods of finding the numbers in Pascal's triangle besides just adding the two numbers above it, we can actually just do the 18th row. To do the 18th row, we're going to use something called combinations, which you've used in other courses for other reasons, like probability. There's a combination, and the 18th row would look like this. I'm going to show you using combinations of, what's it called, like the way you write it. I'm blanking on the vocab word, but like this is how you write combinations. Then I'll show you how to do the combinations. I'm just going to show you how you write it to start. So the 18th row in Pascal's triangle would be using combinations 18, choose 0, and then 18, choose 1, and then 18, choose 2, and then 18, choose 3. Can you follow my pattern? What would be the very last thing in the row if you're following this pattern? It would be 18, choose 18. I'll show you in a minute. But I'm actually not going to go too much involved into it, but there is a formula at the bottom of the page of how you would find the number. The formula is here. It involves factorials, which is why we review factorials. It does have to do with probability. It has to do with the number of ways you can choose different things. But the way we're using it is there's 18, it's to the 18th power, and we're finding the 0 term. It's to the 18th power, we're finding the first term. That's like how we're using it to make that 18th row. We can do this on the calculator very easily. So you got a calculator handy?
Yep.
Now you kind of already know if you have an older version or a newer version. But if you have the newer version, you can just go math, probability, and then number 3 and just type in. Here's an example. It says to do 8, choose 2. It comes up with a C, and then you put the 8 first and then the 2 first. Both of those are ways that we can write combinations. If you have the older calculators, you have to type the 8 in first. Then you have to do math, probability, number 3, and then type the 2. So try it, see that you get 28. If you don't get 28, let me know so I can help you. If you don't understand how to type it in, let me know so I can help you. Okay, so instead of using Pascal's triangle, we can use what's called the binomial theorem, which instead of using Pascal's triangle to find these numbers, we are using combinations. So instead of writing everything out, you're going to just put the number of the exponent over 0, then the number of the exponent over 1, the number of the exponent over 2, and so on until we're filled out the whole row. And then everything else in here we've talked about. We talked about how the first term is to the whatever that exponent is, and the second term doesn't exist in that. And then here it's 1 less than, here it's 1. Here it's 2 less than, here it's 2. So that's the rest of this formula, just showing you what we already know, or should know. So how do we expand this using combinations? You're first going to write, what's the exponent? 3 over 0. Then you're going to do the thing that we were just doing, where you do your first term from the binomial x to the third, and then 1 to nothing. Then we do 3 choose 1. We'll have 3 choose 2, and we'll have 3 choose 3. So this is instead of doing Pascal's triangle. It's the exact same information instead of doing Pascal's triangle. So this is going to be x squared, x, and then no x's. The second one will be 1 squared, 1 to the third, and then we will put, I'll get it, addition signs. So what you're going to do on your calculator is you're going to do the combination 3 choose 0. You're going to do combination 3 choose 0. Now you do not have to go do like math. You don't have to do like math, probability, what was it, 3 every time, you can just hit like second enter and just go change the numbers every time. So I want you to try it on your calculator. Find each of these answers using your calculator. Is it the one we just checked? Yeah. So you can just hit second enter. You don't have to retype it. And just change the numbers. Second enter, change the numbers. Okay, so you should get, you do, but we already knew that. This is really a shortcut for those not first few Pascal, right? So the rest of this would be x cubed plus x squared plus, oops, x. So if you're going to expand this one out, we don't necessarily need to find the full answer. Let's go through how you would write it with combinations. What would the first one look like? 4 choose 0. Then we would have 4 choose 1. 4 choose 2. 4 choose 3. And you stop when you get the same number on top of the bottom. 4 choose 4. Then our 3x will be to the what power? 4. Then third. Then second. Then first. Then none. And our negative 2. What happens when you take a negative number even amount of times? It becomes positive. If you have a negative number an odd amount of times, it stays negative. So we will have signs that switch every other term. And from there, you simplify it. I'm going to write the answer up, but I'm not actually going all the way through the work. Is this the right one? Yeah. Wait, I think we already did this one. Yeah, we already did this one. It's just the same thing we did on the other page, just a different method. Right, that one that we already did, just on the other page. Yeah, different method. Okay, so then this says on the ACT, they will ask you a question, which is very easy to figure out if you know the pattern using combinations. Find the 7th term of 4x minus y squared to the 9th. So I do not want to write all the terms out and then count and figure out which one's the 7th. So you can actually jump straight to the 7th term if you know the pattern. All right. Yeah. What? So remember, there's how many terms?
Oh, there's one more.
There's 10 terms. So it's not actually 9 choose 7, it's 9 choose 6. So we can write ourselves a note. This is one less than what we're supposed to choose. Than what to choose. One less than the term choose. I don't know how to say this. Ideas? One less than term needed. Well, there's 10 terms, but I'm asked to find the 7th term. So that number is going to be one less than what you're asked to find. Okay? Then we do 4x. And we got to figure out to the. Let me come back to that in 1 second. Leave that alone for a moment. Then you're going to do negative y squared to the. This one is going to be the same as one less than term needed. So that's the same as that 6 over there. Those are the same. And remember, when I add together these two exponents, they have to equal a total of 9. So the blue one is going to be the total minus how many that one is, or you can look at it being just subtract these two numbers. Yeah, so somebody said 3. So we're doing, what is 9 choose 6? Calculator, 9 choose 6. 84. And we do 4, that's 4x to the third. 4 to the third is 64, x cubed. And we do negative y squared to the 6. Negative's going to change that positive. So we'll have y to the, what do you do when you do power to a power? Multiply, so y to the. And I just have to calculate that. What is that? 5,376. To the third, y to the fourth. Let's try the other two. If you think you got it, work ahead. So the fourth term of x minus 3 to the 8th. What am I going to be choosing? I'm going to have what and choose what? From how many? 8. Choose 3. It's going to be one less than the term that we're finding, and that's because there's like more terms than 4 or than 8. There's 9 terms. And then my next is going to be x to the 8 minus 3. Subtract those two. And then we'll have negative 3 to the third. So we have an 8 and a 3. The middle one's 5. And then this one is a 3 again. Let's 8. Choose 3. 56. And we multiply it all together. 1, 5, 1, 2, x to the 5. All right, set up the next one on your own. Set up the choose, set up the how many you have of each term. There really isn't a line there. I go by accident close to it. Maybe like a fraction, there's not a fraction.
Yeah.
Like 8/3. It accidentally happens to me sometimes. There really isn't a line here though. It's like muscle memory.
Yeah.
The brain just does it. So how many choose how many? 10 choose 5. So then we've got y squared to the 10 minus 5, which is 5. And then we've got 2 to the 5. that what you were saying? Is that the right answer? It must be. Yeah. Wait, 252 times.
Oh.
All right. Yeah. Wasn't paying attention to the calculator. We do. So to get started, so you have less to do over the weekend. It isn't as long as last class.
That's good.
But combinations, you're more than welcome to use your calculator. Some of it is easy to figure out. So practice it. So if you're taking your ACT tomorrow, you're like fresh in your mind, and then probably none of the questions do that. But maybe.
I got these weird C's next to mine.
Did you think there was one on there?
He saw us C and number C.
Oh, the combinations. So if you see combinations on your, I don't know, if you see that on the calculator.
So this is before I ever learned to take, like, I just realized there, like, I'll tell you
Right, the matrices, you all know what to do this time, right? I saw it in your book. There was a matrix question and it had to do with multiplying matrices. I'm not a copy.
Is it odd?